In today's video, we'll be learning about these little amazing electronic components called potentiometers. They are very, very useful in the world of electronics. The way that it works is that if you connect here and here, or here and here, you're getting the variable resistance that is dependent on the position of your dial. So this basically increases or decreases the resistance in here, and you can use that to control something else. Now, let us connect this to an Arduino board so that we can actually read the value of the potentiometer through the Arduino. So we need to set up our Arduino. So you have the Arduino cable. You can watch the previous videos to see how we work with this. So we're going to connect this to our computer. And then we're going to start replacing things. So from this circuit board, we are going to remove the batteries, right? So first, remove this completely, set that aside. Then we are going to get power from the Arduino. We're going to get from the 5V, connect it to the positive, and then we are going to get from the ground or negative, and then connect it to the negative here. So just to show you that that's a replacement for our power, you'll see that our LED is on, and as you turn it, this is actually giving more power than the batteries because these are 5 volts, not the 3 volts on the other battery. So now you can see the brightness better. All right, still working. However, what we're going to do is that we are going to remove the LED because we just need to measure what's coming out of the potentiometer. So we'll remove the LED. Put that aside. So now we have the potentiometer, we have power. Then we are going to get power from one end of the potentiometer, the extreme, one of the opposite legs, and then connect it to the positive. And then from the other end of the potentiometer, and then connect it to the negative. Now you have to be careful here so that you don't short circuit anything. Make sure that these two things are not connected, all right? Yeah, so now what's happening is, in our potentiometer, we have one side connected to negative, we have the other side connected to positive. Now what we are going to do is that we are going to connect this middle side to the Arduino. And specifically, we are going to connect it to the analog pin. If you've watched the other videos or are familiar with Arduino systems, you will know that the analog inputs collect analog signals as opposed to the digital inputs which collect digital signals. The differences between analog and digital are well explained elsewhere. But the rundown is that analog is a variance in value from one extreme to another extreme. So from 0 to 10,000, 100 to 500,000, whatever it is. Digital, however, is one of two values. It's either 0 or 1, on or off, maximum or nothing, right? So digital pins require a specific digital signal. Analog pins require a specific analog signal. So in this case, this arrow is going to connect to A0 on the Arduino, which is an analog connection. So we grab one of these again, and then get the middle pin, bring it to our Arduino, and connect it to A0, like that. And then our connection is complete. So let's do some code. Our code is special in this case because this is going to be the first time when we are using something called the serial monitor. The serial monitor is a handy little component of the Arduino programming environment, that allows you to see information from the Arduino on your computer. All right. We'll learn about serial monitors later, but for now, we'll just include a small component that allows us to see the value of the variable resistor. So let's write our code. So in our code, we already have the void setup, we have the void loop. What we are going to do is at the very top before the setup, we are going to define potentiometer as pin number 1. What this section of code is essentially saying is that anywhere you see the phrase potentiometer pin, look at it as pin A0. Again, variables, we've discussed it in the previous videos, but essentially we are creating a variable called potentiometer pin and assigning it the value of A0. So every time the Arduino sees the phrase potentiometer pin, it automatically replaces it with that specific pin. Then we are going to create a serial begin. Now serial.begin is a special command that starts the serial monitor. The serial monitor is basically a way of communicating with your Arduino board. And what happens is that once you begin the serial monitor, the Arduino IDE, or this programming environment, begins listening to the Arduino board for any commands that it's sending back and forth. Think of it as a way of your computer communicating to the Arduino board while it's running a program. And you can make it send any sort of information back and forth. So in our void setup, we'll have serial begin. And then in our loop, we shall say serial.print, which is basically saying print the information that you're getting from the serial monitor. Serial.print, but in this case, we're going to say serial.println, which basically prints the value on a new line. And I can show a quick demonstration of the difference between those two. And then in this case, we'll now say print the analog version, of potentiometer pin. Let's just copy and paste this. You close the analog read and then close the serial print and then add your comma. And then we are going to ask it to delay for 100 milliseconds so that it doesn't run by too quickly. So the 9600 is the speed of the serial port. Again, we'll not go into those details, but just know that in this case, this has to be 9600. And then in the loop, every single time it runs through the program, it's going to read the information from the serial number. It's going to print it on a fresh line. And then it's going to collect the information it's going to print is going to be the analog value that it has read from potentiometer pin, which in this case is A0. So let's upload this and test it. I seem to be getting an error. Okay. I'm getting an error because my port was wrong, but this should be fine now. All right, so my Arduino board is communicating. I've not had any issues. Now, in order to see the information that's coming out of the serial port, you need to click on this little icon in the top left corner, top right corner. And if it's working, you'll begin seeing a series of numbers. That series of numbers is actually representing the value that you're getting from the potentiometer. So as I turn the potentiometer, you're going to see that value changing. So I'm slowly turning it towards the opposite end, and you can see it's going to all the way to 0. And if I turn it the opposite end, it's going all the way, and I can stop. I can basically stop at a certain point and the value will be 174. One thing to take note of is this is not the value of resistance. This is not the value of resistance. It's the value that ranges between 0 and 1024. All right, so if this value is not resistance, then what is it? Because we know that the maximum that our resistor has is 10K. I know that the minimum is 0, but these numbers don't coordinate to anything that matches the resistor. What it's actually measuring is the voltage that's coming out of this middle pin based on the resistance. Remember that on one end of the variable resistor you have 5 volts, and on the other end of the variable resistor you have ground, or basically 0. So if this is your resistance, the position of the potentiometer will determine a certain voltage. So imagine if this is 2.5 when it's at the center, and then when it's here, because of the resistance, it might be like 0.5. When it's here, because of the resistance, it might be like 4.8, right? So depending on the rotary position of your potentiometer, the voltage that's coming out of this middle thing is going to vary. And what is happening is that because this pin is being connected to S0, then S0 is reading voltage. However, it is reading voltage as +5 maximum and 0 minimum, right? But it is doing something called analog to digital conversion. And so it is basically saying that, yes, I am seeing a maximum of 5 and I'm seeing a minimum of 0, and in between there's like 1, 2, 3, 4.8, 4.5 etc. But I'm going to convert this into an analog signal that I understand. And how it does that is through something called analog digital conversion, right? And the way that it does this is through, it's going to get a little bit technical here, but bear with me. It's going to do this through an analog digital converter that has 10-bit resolution. Again, we'll discuss this later. This is just for understanding. Resolution, right? So 10-bit resolution is basically represented as 2 to the power 10. The 2 comes from the way binary, the way PCs work, the way computers work, which is basically binary. Everything is like a multiple or a power of 2. So 2 to power 10 is 10,024. I don't know why I doubled this last number. So what it's doing is basically saying that on this scale of 5 volts to 0 volts, I'm going to assume that this is a 0 and this is 10,024. So depending on the resistance that it's reading, it's going to convert that along this scale. So doing some quick calculation, if let's say it's getting 2.5 volts, what's half of 10,024? That is 512. Let's just cross-check that. Yeah, that's 512. So if we come back to our reading, we can basically say, let's take it to the point where it's maybe 512. So this would mean that this potentiometer is basically now in the center, because the voltage reading out of that is halfway between 5 volts and 0 volts. If it's maybe, so again, the variance, I don't want to stress with the math right now, but you'll find that if it's at this point, you'll find that maybe it's like 200, if it's at that point, maybe it's 736, whatever it is. But what's happening is that the analog to digital conversion is using 10-bit resolution to convert 0 volts, to convert the value between 0 volts and 5 volts into 1024 and 0. All right? Now that will come in handy later, but for now, that's what we need to understand. So I know that we dived off a little bit deep into the deep end towards the end, but I wanted this to be a foundation for understanding, one, the electronics within a potentiometer, how it works, how it varies the resistance, and then two, to understand how we can use an Arduino board to get the value of that resistance from the potentiometer. However, in this specific case, because of how it's connected, it's not truly getting the resistance, but it's getting the voltage that is coming out of the center pin of the potentiometer. And using that voltage, using analog to digital conversion, it is then giving us a number that we can play with. So think about it this way. If you're trying to control light, you can tell your Arduino that dim the lights if the value of the potentiometer is 200, or make them bright if the value of the potentiometer is 1000, right? So you can use that information in very interesting ways, but what you know now is that you can get data from a potentiometer into your Arduino and then view it on a serial port. I hope that was helpful. I'll see you in the next video.